So good afternoon. I'm here instead of Otakar Cherba, who wasn't able to come. But I think that on the internet agenda, there is my name. So some can be surprised, some not. So I'm here to introduce you our dataset, which is POI SDA for apps, points of interest. SDA for apps, it's a name of project in which this dataset was made. What is our dataset? We collect data from different sources, points of interest important for tourism and traveling. We use different input, different sources, different contributors, and these input data are heterogeneous. We run the data through some harmonization process to have them in common data model. The resulting data model is based on standards, semantic description, and link data. We publish it on a map portal and through Sparkle endpoint. And it's provided under Open Database license. Sources of data are the main source is OpenStreetMap. Then we get our data from some other sources with open data. We also have contributors from local regions, some regions in Czech Republic, some in Italy, some cities, open data from Prague. We are working on data from Vienna now. Just get back. Now we are working with data which are based only on their coordinates. If their geolocation is, if they are geolocated on coordinates, but we are going to work on involving also other geolocations or other types of geolocations as addresses and so. How the common data model looks like. We have 7 classes in the data model with several attributes. There are labels and descriptions, geometry. In geometry is also primary geometry and also secondary, which means that if you have a point or a feature that can be described as point or geolocated as point or either as area or so. So it's in the secondary geometry attribute. Then there is classification. The classification, actually there are 3 classifications. One is down on the slide, and it's the main one. It's the obligatory one. It's reused from open navigation ways classifications, and the other 2 classifications are based on OpenStreetMap. Some contact information, because as I said, the dataset in the dataset are the tourist information. So the contact information are addresses or telephone number or so. Tourist information, opening hours, accessibility, internet access, and what's important are links. The data are linked with other sources. There are links to Wikipedia, to some photos. There is also important link to state within the feature lists. And there are also 2 attributes, same as and exact match, which are actually the same but different standards, and they link to the same feature but from different source. And then metadata. These attributes we use either our own standards, or how to call it, attributes which are with the POI or POI preface, but also we try to use existing standards, for example, GEOS or RDF-based for the labels. And this data model, we don't find it like the non-changeable, so it's flexible, and we are willing to add attributes or change attributes according to requests or according to data we will get. Then there are just more to or specific about the model are two features: airport and food. And for these two types of features, for each of these there is one specific attribute. So it shows that there is flexibility of the model. And what I forget to mention, that the classification from WAIS, so it's connected. It's not like string. It's connected by URI, by a link to the vocabulary. Identifiers of features are URIs. They were chosen because they are, from their definition, they are unique. And you can see down on the slide an example. It's combination of country code, acronym of category of the feature of the POI, and coordinates in order longitude, latitude. As I already said, the data are linked to some other sources. So there is the first link with classification to reused vocabulary. There are links to photos and pictures and some other features. The link to country is like based on topological relation. The POI dataset fulfills the requirements of 5-star rating system for linked open data. It's accessible through Sparkle endpoint, so you can make your own query to get the data you want, and it's licensed by Open Database license. We provide them in, or it's provided in structured data and machine readable data, and the prime non-proprietary format. We provide them in RDF format, but it's also possible to export them in some other structured formats. It's identified by URI, so it's the identifier for each POI is unique, and the data are linked with other sources or informations. Because we collect data from different sources, it's necessary to make some harmonization before implementation in the data set. So we transcript data to structured. We prepared common RDF vocabularies and mappings, filtering when necessary, adding informations like those links to countries, and transformation and export to the RDF format. For the data harmonization, the technology which was used was based on XSLT templates, which ran on a Saxon processor. Just the scheme of the harmonization, example of the RDF code. This weekend, or on the beginning of this week, we had more than 4,700,000 POIs. Since next week, we will have more than 6 million POIs. The coverage is mostly in Europe, but we have also data from Africa, South America, and so. And the 2 more POIs, which I mentioned, will be next week. These are data from some Asian countries and from US. These are top 10 countries this week. In Germany, there is more than 1 million POIs. In all of these top 10 countries is more than 100,000 POIs. Just a quick comparison with open POIs. This was made on in small areas, small areas in different countries, and with different features. And so you can see that, that the POIs are not the same. Somewhere we have more, somewhere we have less. And this is an example of it's just the Sparkle endpoint, how we provide access to our data. So you can try it on the languages down. You can make your own query and choose data based on attributes you need, or based on location, and so. It works. And we also provide a map client to access our data, which is based on HS layers. In Central Europe, we have specific tiles for cycling and biking, and it's also connected with some other informations like Panoramio or Open Weather Map. We also have a web page where are also links to the Sparkle endpoint and the map client, which you can find on the languages here written. The web pages are in several languages, but actually I'm not sure if they are in German, but in English definitely. And next steps. So because the project or the data set is quite new, we worked on it since last year. So we are going to extend the information resources, optimize data model and data storage, because the more data we have, the more some cartographic challenges occurs. Also, we are going to work on context-based application. It means that if user open the map client and needs to find some, or he's in some, it happens something like he's hungry or he's injured, so not to have to check all these layers like hospitals and public transport, and so he will just check the one context, I'm injured, and it will open all these necessary or helpful layers automatically. Also thinking about advertising and so. What we think is quite innovative about our approach is that we use common data model for the data set. So even if we have data from different sources, we want to be in the same data model, to have the same data model. We are also reusing existing standards. So we try to use existing standards. These data are linked, and they are accessible through Sparkle endpoint. Just a list of promotion where was this presentation promoted, and contributors of this project are Bochemia University and some other Czech institutes and Baltic Open Solutions Center. So thank you for attention.
Yeah, thank you. Questions? This one first.
Hi, there's probably lots of questions that I could think of, but some people were talking earlier about this problem that happens in lots of things, even in how you plug things into your computer, that there's lots of standards. So in your case, there's lots of data models that exist already, and also lots of databases of points of interest. So what people tend to do is, oh, well, we'll create another standard to try and solve the problem of, so it will be the one true one. But all you're left with is even, lots of standards plus one. So my question is, why didn't you, rather than create a new data model and a new database, why didn't you try and improve one of the existing ones?
You mean one of the existing, like with the same approach we have, or just? Yeah,
so why not kind of? So if there's problems that you've seen, why not improve a data data model and format? Or rather than try and start the points of interest from afresh, why not add ones to an existing database so you're not starting from a blank canvas?
Actually, it's because when you have like this set, so when you start it yourself or with your team, you know what to use, or you know what you want to use. And if you're trying to improve someone else's product, it can have some ways or some details which you're not like common with or so, I would say. And the other thing is that we actually try to use standards which are already used. So we try to not to come with anything or something new, like really new, but try to reuse existing and make it as smooth or as nice, like common as possible.
Okay, yeah, cool. I think there was another question here, right?
Thanks. Hi, I'm Ludwig. Would it be possible to assign multimedia data to a point of interest, such as an audio and picture or on video? And if yes, what would I have to do in order to get an assignment between a point of interest and a multimedia file, such as an audio file, for example?
I guess it should be possible, but actually the truth is that I'm not like that. I can't see quite a lot into the technical part of this data set. So maybe we can talk later and just give you some contacts or so.
Of course. Thank you.